2 in the last video. So we're looking at unit 3. So what's the tangent of negative 5 pi over 6? So once again, use your unit circle. Okay, negative 5 pi over 6. Let me erase the previous highlight. Here is negative 5 pi over 6. Okay, so really we're talking about, you can think of it as a negative 150 degree angle, if that helps. So I'm going to draw that on the notes so that we see what it looks like. So here's my negative 5 pi over 6 angle. And we just said that was about a negative 150 degree angle, if the degrees make more sense. Oops, not 15 degrees, 150 degrees. So you're going to draw your reference triangle just like before, and you got to find your reference angle. So here's my right angle. I know this is negative 180 degrees, so the difference between these two, that would be a 30 degree angle, okay? So my reference angle here is 30 degrees, which means the other angle is 60 degrees, which means I have a 30, 60, 90 triangle. So if you look back up at your special right triangles, across from 30 degrees, the 1, and your hypotenuse is 2. So I'm going to fill that into the picture. Across from 30, I have 1. Across from 60, I have radical 3. And across from my right angle, my hypotenuse would be 2. You'll notice that since this is in quadrant 4, both the radical 3 and the 1 is negative, okay? Because the radical 3 is to the left of the origin, which means it's negative. The 1 is below the x-axis, which means it's negative. So to figure out my tangent, I have tangent of negative 5 pi over 6. That 5 is real bad. Let me erase that. Ooh. Negative 5 pi over 6. Okay, again, tangent is opposite over adjacent. So my opposite side, again, you're looking at this angle to figure out. Whoa, I did not mean to do that. You're looking at this angle to figure out what your tangent is, what that ratio is. So my opposite would be negative 1. My adjacent would be negative radical 3. Whenever you have a negative over negative, they cancel out and it just becomes positive. So this is 1 over radical 3. And then you got to make sure that you radicalize the denominator. So I got to get rid of that radical 3. So I have radical 3 over radical 3. In my numerator, 1 times radical 3 is just radical 3. And radical 3 times radical 3, all that means is the radical canceled out. I'm left with just 3. So in this case, my answer would be radical 3 over 3. Just heads up, some of the questions on your assignment ask, like, is this positive in the fourth quadrant or whatever? Is tangent positive in the fourth quadrant? Just draw a triangle and see what happens, okay? In this case, both your opposite and your adjacent sides are negative, which means when you put them into a fraction, they cancel each other out. All right, then letter B, 675. If you look at your unit circle and you look for a 675 degree angle, you will not find one, okay? Because again, the angles only go up to 360 degrees. So what I'm going to do instead is find a coterminal angle, okay? I'm going to find a coterminal angle that lines up with 675. To do that, I'm going to take 675 minus 360. So if you type that in your calculator, you should get 315 degrees. So if you look at your unit circle then, and you try to find 315 degrees, you'll find it, okay? It's right there. That would be a 45 degree reference angle because that's the 45 degree away from 360. So I'm going to draw a picture of this. Oops. So this is in the fourth quadrant. The angle looks something like this. The angle really is opening up like that. I'm going to draw my reference triangle. Here's my right angle. And since this is 315 degrees and this is 360, between those two, 360 minus 315 is 45. So my reference angle here would be 45 degrees, which means the other one is also 45 degrees. So now I'm using that 45, 45, 90 special right triangle from the last page. In that one, both of your legs are 1, and your hypotenuse is radical 2. Your hypotenuse is always positive. In this case, the top leg is in the positive, so that top one is positive. But the side one over here, that would be negative because that one dropped below the x-axis. So to find the tangent of 675 degrees, again, I look at that inner angle, that 45 degree angle, and I do opposite over adjacent. My opposite side would be -1. My adjacent side would be 1. -1 over 1 is just -1. So there's my answer. All right, then lastly, example 4. It says evaluate the secant, cosecant, and cotangent of 135 degrees. So these are your reciprocal trig functions. So you might need to think, okay, which one goes with sine, which one goes with cosine, which one goes with tangent, to figure out which one's which. First of all, though, I'm going to draw a picture. 135 degrees. If I look at my unit circle, you'll see 135 degrees is right here. Okay, so I'm going to draw that back on the notes. So it looks something like this. Okay, and I draw my reference triangle. So this is 135 degrees, and this is 180 degrees. The distance between those two would be 45. 180 minus 135 is 45. That's my reference angle. Also means the other angle is 45 degrees. Once again, I fill in all three sides. That way I can actually figure out those trig functions. The two legs of a 45, 45, 90 triangle are 1 and 1. And then your hypotenuse is radical 2. You'll notice that this bottom one is actually negative because it's to the left of the origin, okay? The other one is positive because it's above the x-axis. So I'm going to fill in these three trig functions now. So I have my secant of 135 degrees, I have my cosecant of 135 degrees, and I have my cotangent of 135 degrees. If you don't remember which one's which, you can always look back at section 6.1 where it listed out which of these ratios each one of this is. So if you look at secant, secant is your hypotenuse over your adjacent side, okay? If I go ahead and plug that in, I know my hypotenuse, again, you're looking at this angle, the reference angle, to figure out your ratios. My hypotenuse would be radical 2, and my adjacent side is -1. Radical 2 over -1 is just negative radical 2, okay? So there's my secant. Then my cosecant, we know, if you look back at 6.1, that's hypotenuse over opposite. So my hypotenuse is radical 2, my opposite side is 1. Radical 2 over 1 is just radical 2. And then lastly, cotangent, that's adjacent over opposite. My adjacent side here would be -1. My opposite side would be 1. -1 over 1 is just -1. And now you found them. So again, if you forget which ratio is which, and because the reciprocal ones are not in SOHCAHTOA, so they're obviously a little bit harder to remember. Just look back at 6.1, it has it listed out there. Now, letter B, it says, what are the secant, cosecant, and cotangent for the angle -10 pi over 4? Okay, so -10 pi over 4, if you look at your unit circle, you are not going to find that, okay? That's because it's actually bigger than 2 pi. 2 pi is right here. That's the biggest angle in radians. So what I'm going to do is find a coterminal angle, which is a little bit different than when we're doing it with 360 degrees. So 1 full time around the circle is 2 pi. It's actually what we call a period. So 2 pi. You, however, need this to be written with a common denominator if you're going to be adding this to -10 pi over 4. Make sense? So what I'm going to do is I'm going to rewrite this as, okay, this is over 4 instead. You can kind of ignore the pi. It's just kind of like a variable. What over 4 is the same thing as 2? That would be 8, okay? So I multiplied 8 times 4. Or, excuse me, 2 times 4 to get 8. So what I'm going to do is, with -10 pi over 4, I'm going to add 8 pi over 4 to figure out a coterminal angle that's actually on the unit circle. In this case, you can kind of ignore the pi and you can ignore the 4. Okay, all you're doing is adding -10 plus 8. -10 plus 8 gives me -2. The pi stays the same because it's kind of like a variable. And then this is all over 4 because, again, we're adding fractions. You don't add the denominator. -2 over 4 actually reduces to -1/2. I'll do it without the pi to confuse you a little less. That's the same thing as -1/2. So, excuse me. So I'm going to reduce this as -pi over 2. You can put a 1 there if you want to, but you don't have to. Okay, so now on the unit circle, if I try to locate that, negative pi over 2, you'll notice that's down here. Okay, that's negative 90 degrees. That helps you think of it that way. So I'm going to draw that. You'll notice this is actually on the coordinate plane itself, which makes it different than what we've done before. So I have my angle is something like this. Oh, that line really screwed up. There we go. So my angle actually looks like this. You'll notice I cannot draw a reference. Okay. What I can do is pick a point that's on that terminal side of the angle. Okay, so once again, my terminal side would be this side. I can just pick a point on there. The easiest one to do is going to be, okay, my x value, since I didn't move right or left, is 0. And then if I go down 1, then my y value would be negative. I just picked a random point, but always pick one that involves 1 because that's easier. Now you've been given an x and a y value. Alright? There is a rule that I'm not going to really explain the logic behind it, since we're doing this online and I don't really have to do that. But I'm going to tell you the rules for how to apply an x and a y value to all 6 trig functions. So here's your rule for that. So this is very, very, very important information. So whenever you end up on one of the actual axes, like we just ended up at a 90-degree angle, negative 90-degree angle, use this rule. So, for example, if I told you to find the sine, well, sine is equal to y. In this case, my sine would just be negative 1, because that's that y value of that point that I picked. So in this case, I'm doing secant, cosecant, and cotangent. So I'm going to start with secant. Refer to my nice thing here. It says secant theta equals 1 over x. So in this case, that would be 1 over 0, because the x value of that point was 0. You cannot have 1 out of 0 cookies. That does not make sense. Okay, so I'm going to say this is undefined. Then I have cosecant of theta, which is 1 over y. So in this case, that would be 1 over negative 1, which is just negative 1. So there's my first answer, negative 1. Then I have my cotangent of theta, which equals x over y. So 0 over negative 1. If you have 0 out of 1 cookies, that would just be 0. So my answer is 0. So whenever you do end up with one that's actually on one of the axes, your answers will pretty much always be 1, 0, or undefined. And it is possible to get an undefined